All right, so I think I said we're gonna do number 3 before, but it was just a fake out. I think we're actually gonna do number 4. Reason is I think number 4 is a little harder, so it makes more sense to do that one. And then, yeah, I think the next one we'll do is the general problem. Okay, but yeah, you please have specific questions ready to go on what is confusing about this. So this one says two spherical objects whose centers are 8 centimeters apart, remember it needs to be in meters, have equal negative charges and repel each other with a force of 90 millinewtons. If you're wondering which one is that, yeah, millinewtons. What is the charge on each of them? How many extra electrons are on each of them? Whoa. We're still going to be using the same equation. We are going to modify it just slightly. Okay, so let me just rewrite it. K times Q1 times Q2 r squared. So this gives us a radius as 8 centimeters, which, if you do your conversion, should be 0.08 meters. Our Q1, we don't know. Oh, wait. Well, Q1 we don't know. Our Q2, we don't know. But we do know Q1 is equal to Q2. And if we're multiplying them, that's also the same as Q squared. K is still the same. I'm not going to do the unit. Okay, so for this one, we do need to rearrange this. All right? We need to rearrange this in terms of the single charges or one of the Q's. Okay? And since it's squared, you're going to see we're going to do a little adjusting. So that's going to be the same as K times Q squared divided by R squared. All right? So why don't we just get Q by itself, right? So first I'm going to do is R squared. Remember, we still have this term over here, times R squared is equal to K times Q squared. Well, divide by K. It's going to be Q squared is equal to times R squared divided by K. And to get rid of that square root, we just square root everything, and we are going to get the charge is equal to the square root of the force of the electrostatic force times R squared. Now, if you were to take this square out because of the square root, you would need to take that R and put it outside of the entire equation. And actually, this should kind of extend like that. Okay, and now we just plug everything in. Everything should be in the correct unit. What else do they say here? Oh, our force, forgot to put that in here, is 9. Don't worry about that. 9. Really? So, if you were to look here, it's going to be 9, 1, 2, 3. So that is going to be 0.009, right? 1, 2, 3, so 2 newtons. Okay? So we get 0.009 newtons times R squared, so 0.08 squared. I believe that is what, 0.0064? 0.08 times 0.08. Yeah. That's 0064. And that is going to be divided by 9 times 10 to the 9th. And the square root of that. So if you type that in, let's see. So if you do this, you should get 8 times 10 to the negative 8th. That's going to be our Coulomb charge here. Right, very small. So that's going to be the charge on Q. All right. But it also asks how many electrons are on each of them. Okay, little kind of a weird question, right? Well, we can use the total charge divided by total charge of an electron. Remember, it's a very tiny number. So we know what the total charge of one electron is. We know what the total charge of our objects is. So what we can do, and you should be able to find this information on your sheet. So if you just look it up, yeah, right there, right? Charge of an electron. So we can do 8 times 10 to the negative 8th divided by the charge of one electron, which is it negative? Well, these are both negative, so it doesn't matter. 1.6 times 10 to the negative 31. Very small number. And if we do that, we should get about 5 times 10 to the 11th electrons. Very big number. There you go.